Well, hello everybody, and welcome to the 24 Hours of PASS. We're excited that you can join us today for Matt Usher's session on Introduction to Microsoft Analytics Platform System. This 24 Hours of PASS event consists of 24 live webcasts, and these sessions, the recordings of these sessions will be available next week on www.24hoursofpass.com. My name is Kendall Van Dyke. I am a SQL Server MVP and a chapter leader in Orlando, Florida. And I have a few quick introduction slides before I hand over the reins to Matt. Some ground rules: he's going to speak for 40 to 45 minutes after we're done with the introduction, and then we'll move on to the Q&A where you can ask any questions that you might have at that point in time. Matt, if you want to flip to the next slide. There we go. Good. Now, if during the session you require technical assistance, please raise your hand by clicking on the hand button in the controls on your right-hand side. You might want to also maximize your screen with the zoom button on the top of the presentation window if you're having a hard time seeing what's going on. And as questions come up throughout the session, please type them into the question pane on the right-hand side or in your control panel as well. And I'll be moderating the questions throughout the session. We'll try to queue them all up and ask the most asked ones or the most interesting ones to Matt here at the end. We would like to thank Microsoft. They're our event partner and one of our global sponsors for PASS. And 24 Hours of PASS would not be possible without their support and their dedication, and they're the reason that this event is available free of charge. So thank you very much, Microsoft, for your support of 24 Hours of PASS. And on that note, I would like to invite you to all attend the upcoming PASS Summit taking place in Seattle, Washington from November 4th to the 7th. There will be over 190 sessions with world-class SQL Server experts. In fact, the sessions were just announced today. You can go to the Summit website and see all of the sessions and pick and choose what you'd like to attend. This is planned and presented by the SQL Server community for the SQL Server community, and PASS is single-handedly the largest gathering of SQL Server and BI professionals. You can join over 5,000 of your closest SQL Server friends from all over the world. And the PASS Summit is also a great place to network and meet face-to-face with experts, peers, authors, MVPs, and folks just like you. And more importantly, the PASS Summit delivers on providing you with the answers to your SQL Server issues, along with the knowledge, strategies, and skills that you need to stay ahead of the curve. If you contact your local PASS chapter, they have discount codes that will save you $150 off of your registration. So make sure you reach out to your local chapter leaders and get that code and use it when you register. Also, prior to Friday, June 27th, the price is $15.95. The price goes up after that. So if you haven't asked your boss to go at work yet, go ask. And make sure you try to get that in before the end of the week. You can find out more about the PASS Summit at www.passsummit.com. And now we're going to hand things over to Matt. Matt, one more slide, I think, and then I hand it over to you.
Oops. Yeah. So Kendall, the speaker bio's up.
Okay, yeah, it's taking just a second to refresh. So just something to keep in mind as you're doing your sessions too. The slides will take 1 or 2 seconds to refresh on everybody else's end of things. So Matt is the Senior Program Manager at Microsoft in the APS team. He's worked in Visual Studio, Office, Windows Server, and even outside of Microsoft. I had a nice chat with him beforehand. He's been all over the place and done all kinds of things. So really interesting guy, and I'm looking forward to hearing his session. You can catch up with him on Twitter as 2_under. And with that, Matt, I'm going to turn things over to you. Take it away.
Great. Well, welcome everyone. I'm going to give a quick overview of the Analytics Platform System. It's Microsoft's essential large big data platform for SQL Server data warehousing. We call it affectionately the turnkey modern data warehouse appliance. So let's start with a little bit about the data warehousing space. Gartner in 2012 came out and said that data warehousing has reached the most significant tipping point since its inception. The biggest, possibly most elaborate data management system in IT is changing. And that was a profound statement, as data warehousing has moved from kind of a backroom operation to the front of many businesses, it really truly has become a change in the way that the data warehouse has been looked at and valued inside the global corporations in the world. So let's talk about kind of the traditional data warehouse first. Let's just break this down into just a few key kind of components of how they worked. Typically at the bottom of the stack, there were a series of data sources that would drive data into a data warehouse. It's your online transaction systems, your ERP systems, CRM, kind of line of business applications. And then typically you would have an ETL tool to take the data out of those individual data source systems and push them into a data warehouse. And then you have some traditional kind of dashboards and reporting infrastructure sitting on top. So maybe some simple or advanced analytics, some basic dashboards and reportings talking about operational systems or quarterly earnings or those kinds of things. But how has that changed? First is just the massive amount of data that is now collected, captured, and maintained inside of many of these systems. Second is the real need for real-time data. No longer are companies looking for data at the quarterly or weekly or even sometimes hourly. The ability to get at data within the business or external to the business is becoming just an increasing competitive advantage for many companies to be able to react to situations that are occurring real time on social media or in competitive environments where they're really truly able to look at the inside of what's going on in the world around them and make business decisions based on the data that they can collect from so many different data sources. Third is the introduction of many different types of data sources coming from the individual mobile devices or content that's being delivered on the web or transactions that are occurring in the internet. Sensor data. Many companies are now automating the sensor information in many of their components of their business. Things like manufacturing companies that are now automating things as simple as a bulldozer or maintenance equipment and collecting that data for use in analysis later on. And then finally, social media, all the sentiment information that's being collected, gathered, and produced in social media, whether it's pictures or videos being posted online or customer comments on a Facebook page or individual tweets or comments on Twitter. And then finally, there's the introduction of truly cloud-born data, so things that are really truly coming out of the non-traditional websites where it's just the www.com homepage for a company or the shopping experience. But even more, the information that's gathered from many of the different resources coming out of the cloud. And so how does APS fall into this, and what does a modern data warehouse look like? So we take that last slide and we look at kind of the components of it, and we see that this is blown quite a bit wider than it ever has been before. We have a variety of data sources coming from traditional structured and then non-traditional, non-structured data sources. We have data management processing level where we're really doing things from grabbing just ETLs, or extract, transforming, and loading data from those traditional structured and unstructured sources into relational systems, pushing them into things like Hadoop, and really pushing them into non-relational key value pair type data stores. Massive analytic systems, the ability to get insight out of streaming systems using tools like HDInsight, and being able to event monitor things that are happening in real time. And finally, kind of some internal and external management processes that are happening around how data is secured and managed and exposed to different parts of the business as well as partners, and how it's shared across companies or operating divisions. And you think about kind of the way that data is being pushed and exposed. So as we move up the stack here, you think about being able to query from a simple place, having the concept of a single query model where you're looking at data that's not only structured in a traditional system like SQL Server or any one of the kind of structured ERP systems that you're familiar with, but being able to have access to the data no matter where it resides. Talking about the federation of ETL tools and being able to push data in and around the system so that it's in the right location at the right time for the right corporate need or the right business need. Managing data quality, so with all of these different data sources, being able to ensure that the quality of the data really truly is conveyed in representing it to the ultimate end user. And then finally things like master data management, where we're really trying to master the single source of data and being able to distribute that across systems so that we can have a single source of truth for many other parts of our business. No duplicated customer information or inventory systems or things of that nature. And finally, at the user front end perspective, you really have kind of a wide need for truly self-service BI, being able to go in and access data that is appropriate for your title and role in your organization, and being able to pull in data from disparate sources and make very smart decisions about where the business is moving. You know, at the corporate and the collaborative level, where you talk about individual business groups or individual business users being able to look at and make decisions based on not only the data they have, but maybe shared across businesses, or exposing data to a partner business or even an external partner and making business decisions together. And exposing it on different devices, so truly enabling not only things like you know, primary dominant usage in Excel, but exposing that data into mobile applications and being able to make the app experience for a particular application responsive to the changing needs of the data being collected outside of it. And finally, the truly forward-looking model, where we think about using all of this data from many different sources in a different way, and starting to do predictive analysis across customer scenarios, and really trying to understand what-if analysis that we've really never been able to truly do well, just because the lack of data or the ability at getting at very large volumes of data very quickly, and to make that predictive analysis efficient for data scientists so that they can go out and really analyze data from all kinds of systems instead of just the traditional structured systems that they had in the past. So when we think about that, we think about kind of the insights of what you can gain from all of your data. So we can talk about how the social web analytics can really give you know, a better insight into the experience of a company. A great example is the city of Barcelona. They wanted better insights into the way that they have government effectiveness, and really wanted to understand how it was working. So what they did was they went out and built a system that collected and analyzed data from its systems, new public sources such as social media, software log files, GPS signals. And they worked with one of Microsoft's partner, a company called Bismarck. The city built a hybrid cloud to essentially store and analyze big data using kind of BI and data services based on Azure HDInsight service, SQL Server 2012, and Excel. Really, it's still in its pilot phase, but what it allowed them to do is provide near real-time insight into structured and unstructured data, gave them BI access using any internet-connected device that could enhance service and business opportunities, improve safety, boost collaboration between Barcelona, its citizens, the businesses that work and thrive there in that city. And it really provided another solution for the business to get insight into what's actually happening, not only from the structured data they have, but the sources of data living inside of their business, inside of the city organization, as well as the related businesses and social media around it, the citizens of the city, and how they can use that to really move forward on improving the effectiveness of the government. And then we talk about being able to grab data from live data. You know, and we talk about a great example is a company called FusionX, and they're a BI solutions company, and they wanted to help a customer reduce energy consumption. To improve efficiency, they used a big data solution based on Azure HDInsight service that integrated and analyzed data from multiple sensors and equipment types. And as a result, they gained valuable insight into building operations. They cut reporting time from 3 months to less than 30 minutes and reduced energy consumption by 20%, all by gathering the data that they could from different places that they never could before. So gathering sensor data, putting that into considerations with things like weather, and how the weather in a region could then dictate whether certain things happen. An air conditioner came on or turned off, and whether they could adjust that based on weather temperatures, or they could adjust building utilization based on the number of people that were involved. So things that they would get out of their typical structured systems. And then finally, you know, using advanced analytics. So there was a group or an effort done by the Virginia Polytech Institute that looked at using big data to do cloud DNA sequencing analysis in a form of life science research it really has the potential to lead to a wide range of medical and pharmaceutical breakthroughs. However, the type of analysis requires supercomputing resources and big data stores that many people and in this case a university really don't have lack of access to. They're costly and expensive, and setting up are difficult and many times prohibitive from a capital expense perspective. So really working through a grant provided by the National Science Foundation in partnership with Microsoft, a team of computer scientists at Virginia Tech addressed this challenge by developing an on-demand cloud computing model using the Windows Azure HDInsight service. So by moving to an on-demand cloud computing model, the researchers were able to have an easier, more cost-effective access to DNA sequencing tools and resources, which allows them to move even quicker in looking for exciting advances in medical research and pharmaceutical research, and really going after the business of understanding the models that they're working with and being able to move forward in a cost-effective way. So now let's turn our attention a little bit to, with that context, a little bit about the Microsoft Analytics Platform System. So it's really a couple kind of key things. The first is that it's an enterprise-ready big data solution. It combines the kind of the industry-leading RDMS SQL Server with a combination of scale-out, multi-parallel processing capabilities, as well as introducing Hadoop as a secondary kind of platform system. From our perspective, we don't consider them competitive, we consider them complementary, being able to use each one of the tools in a way that allows you to query relational data or non-relational data, either within the single appliance or using relational components of PDW and connecting to both systems on the appliance as well as off, like Hadoop running in an external cluster locally in your environment, or even HDInsight service running, running in the Azure cloud. Second, the Microsoft Analytics Platform System, or APS, is really kind of a next-generation performance at scale model. So we do things like near real-time performance with in-memory column store, so utilizing the new Hackathon capabilities out of SQL Server to give us the ability to query very large data sets very quickly. The appliance has the ability to accommodate very, very large growing sets of data, so taking hundreds or thousands of gigabytes and being able to push them into terabytes or 5 terabytes or 15 terabytes or 25 terabytes or even 100 terabytes in larger data sets that are able to grow with the business. And we really remove some of the traditional bottlenecks of data warehousing. So thinking about things like access to data, and if you could imagine a company that records sensor data from a fleet, imagine a rental car company taking sensor data from each one of the cars that it has, and you could imagine that you end up with hundreds of billions or trillions or even up to quintillions of rows of data that traditionally couldn't be analyzed very quickly for insights. And finally, the ability to run all of this concurrently. So not only do we take the opportunity to provide you access to quick access to the data, but we don't require that you take large downtimes for loading that data and interacting with it. And then finally, APS was built to provide a very high return on investment for customers. So we think about things like the price per terabyte for an appliance versus our competitors. We look at the opportunity of providing a single appliance solution that really solves both storage and compute infrastructure with a dedicated MPP architecture that allows the data warehouse to scale very wide, very fast. And then finally, we do this with not buying high-end hardware. So following many of the models we've seen in the marketplace using commodity hardware and being able to use individual servers but use them in a very traditional kind of scale-out scenario by using multiple compute nodes and being able to structure data across them to allow us to achieve very high scale at a very competitive price point. So let's talk a little bit about how this thing works. I know I'm giving you a quick overview, and we're going to run through these as quick as I can so we can show you how some of this actually works. So I'll give you a couple demos in a little bit. But really, the idea behind the appliance is that there's a couple key components. There's some hardware that's built and some software that's built. So we'll start with the software. So really, there's three major components of the APS appliance. There's SQL Server Parallel Data Warehouse, which is a scale-out SQL Server. There's a technology we've built called PolyBase, which is essentially a T-SQL component that allows you to access data stored in Hadoop. And then finally, on an appliance, you have the option of purchasing an HDInsight region, which allows you to create a Hadoop cluster within the appliance. Again, HDInsight doesn't need to be running, or even other flavors of Hadoop do not need to be running in the appliance. It's just another way for a customer to gain value by having the data in a single managed component, in this case, the appliance. And the second part of this is that this entire infrastructure is built by Microsoft from a software perspective, but we work very closely with our hardware partners, Dell, HP, and Quanta, to build out an appliance that works against a reference architecture. So the hardware for each one of the flavors from each one of the vendors is defined and tested and certified And so there's no guesswork as to how do I put together a series of servers and storage and networking infrastructure in order to make this work very quickly. How do I put this together? How do I service it? How do I manage it? How do I maintain it? And how do I upgrade it? Some of the traditional problems with very large data warehousing systems has been taken away by allowing customers to just have a single solution that they can purchase that offers the best of the data warehousing business that Microsoft has learned, as well as at a cost-effective price point. So we're going to jump into a little bit about how the platform works. Let's break down what we've talked about a little bit, so talking about each one of these components. So we'll start with kind of the enterprise-ready big data. And specifically, I want to talk about integrations between APS and Hadoop. So we'll jump into that pretty quickly. So really, many times people see that Hadoop is a solution for so many things. It's big data. It can scale very wide. But it doesn't really solve many of the big data problems. Again, back to that modern data warehouse, we think about all the different things that have to happen. Many times you have customers that have to be able to pull all this data in, but once you have it there, what do you do? How do you get access to it? So you see in the industry a concerted effort to build tools, SQL over Hadoop, or with a new Yarn framework inside of Hadoop, be able to stream data out, but really trying to move back to the traditional tools people use. How do you get access to the data? How do you secure it? How do you manage who has rights to see particular components of data? So just recently there's been many announcements of security companies really coming on into the play of the Hadoop world. And really we talk about kind of how hard it is to get in there, so into the Hadoop world. So many times we see customers who spent a lot of energy and effort really trying to build out an infrastructure around MapReduce jobs and trying to understand the data once it's pushed into Hadoop. And there's a steep learning curve there. But really when we think about kind of the way that it works, there's an opportunity for using Hadoop for really what it's designed for. Hadoop is really a very large scale, very wide scale platform for enabling all kinds of data to be pushed into it. But that doesn't solve the data warehousing problem. It doesn't really allow data to be pushed in an efficient way where you can get access to it very quickly, very efficiently, as well as combining it with the relational data that we have in many of our traditional systems. So APS really kind of delivers on this premise of using both systems, your relational data coming out of your ERP type systems, your OLTP systems, as well as all this new data sources, web logs, those kinds of things that can be put into Hadoop, and how do we merge those to get really truly insightful data that we can use to move our business forward. So the way that we do this is we really build the two together. Inside of PDW, or I'm sorry, excuse me, inside of APS, we have the ability to run HDInsight. We can run HDInsight in the cloud. For HDInsight specifically, it's in the model and deploying it in the appliance. It's really performance tuned within the appliance to optimize all of the components of Hadoop running inside the appliance at very high scale. The infrastructure that we use is 100% Apache Hadoop. There's no core customizations across other than the migration from Linux to Windows to run inside of Windows. And it's the same HDInsight that you can go and download from Azure, run in the Azure cloud, so there's no difference there. We enable through the appliance the ability to use end-user authentication with Active Directory. So using 1- and 2-way trust from the appliance into your corporate network, you can secure the Hadoop infrastructure by allowing access through external tables, and I'll show you this in a bit, access to individual components of data, and not having to require an external component for security and another model and another management tool for ensuring user security and user data protection. Instead, you can use the tools that you already have, Active Directory, group management, and use that right against the appliance and allow individual user groups access to the data that they have appropriate rights to have. Finally, we can manage and monitor all of this using System Center. So the appliance itself has the common management components that you're familiar with. You can watch for the appliance and activity, seeing where CPU spikes are occurring, watching disk transactions. You can watch all of the common things that you would watch in an appliance using the tools that you're already familiar with. And then really, truly, finally, you have the ability to use this appliance against all of the common BI tools that Microsoft delivers, as well as many of our third-party partners, so the Tableaus, the SAP Business Objects, the Cognos of the world. Those are all available to use against SQL Server Parallel Data Warehouse and Microsoft HDInsight running on the appliance. So the tools that customers are familiar with, you don't have to go learn anything new. You can just use the tools that you're familiar with today. So let's talk about how PolyBase works and how we tie this all together. So really, when we think about the islands of data with PolyBase, really what we're talking about is the ability to look at data that's stored in the unstructured world. So really, truly inside of Cloudera, the Hortonworks distributions of Hadoop for both Windows and Linux, as well as the Azure HDInsight service. And really the way that the basic model is we provide just single T-SQL query models which allow you to join both PDW and Hadoop data, really using the things that you're familiar with. So, basic T-SQL constructs, select star from table, inner and outer joins, those kinds of things, without actually having to require the data being moved from system to system. So you don't have to ETL the data or ELT the data out of the Hadoop infrastructure into PDW. You can actually run the front end of your data warehouse directly from PDW and have it access Hadoop directly without actually moving data around. We use the power of the multi-parallel processing component of the appliance to really optimize the time that we run queries. So you can imagine that you have a bunch of individual compute nodes inside of an appliance, and you're able to take that and push that data over into connections from each individual compute node into the cluster of Hadoop nodes, and being able to use the parallelism there for being able to move data back and forth and make decisions on the data, where it should live and how it should be executed against. We support Azure HDInsight, so we allow the ability to do connectivities up into Azure as well as on-premise solutions, as well as Hadoop infrastructure running on any one of the cloud service providers. And then finally, it provides the ability to query non-Microsoft Hadoop distributions, so really the versions of Hortonworks and Cloudera that are available. I'm currently supporting versions 1.3 and all of the 2.x versions coming from Hortonworks, as well as the 4.x versions of Cloudera. So the latest releases available in the open source community are available to be queried directly from Parallel Data Warehouse. So let's talk about kind of how we would do this a little bit. So how would we bring kind of data together? So some of the kind of common use cases that we have. So one of them is just really running high performance queries against Hadoop data. So you can imagine scenarios like, being able to push IS web logs or other web server web logs into Hadoop, and then being able to run front-end queries from PDW and analyze that, say, in Excel directly. We use T-SQL instead of other Hadoop technologies like Hive in order to do this. Really using kind of the T-SQL syntax, we can join the data between what's in Hadoop as well as PDW without having to import it into PDW. And that's a key consideration about making this scenario run very quickly. The second is really being able to take data that's in PDW and cold store it or medium warm store it over to Hadoop as a cheap commodity file system or cold store of data. So you can imagine as a business, you have analytics about your company and data that you've been capturing for years, but you're not necessarily going to want to look at the sales data from 2005, but you don't want to delete it either. So what do? You can use Hadoop to cold store that data, and I'll show you how this is done in just a bit. But essentially allows you to move data over to Hadoop without having to do large-scale ETL processing and building all this infrastructure around how you'd actually move the data. You can actually export the data and move it completely out of PDW and relational data and moving it into Hadoop completely. And so this is really a scenario around driving situations where Hadoop and PolyBase makes it easier to move data into the Hadoop cluster because there may be external processes that are better suited for Hadoop as an execution engine or with some of the tools that you've already built around there. And then finally, the ability to import Hadoop data from Hadoop back into PDW, so using Hadoop as a staging for your load into a large data warehouse. So one of the things that's really interesting about how this is done is using the power of the open source Hadoop infrastructure. So when we talk about how this is really done, really what happens is we make it just like we would with any other query, we have a query decision that's based in PolyBase, and it allows us to take the query as you see it and push it down into Hadoop and making a decision on whether it's quicker to just pull the data back and make a decision in PolyBase or in PDW for executing and displaying the query, or if we actually generate a MapReduce job on the fly, push it down into Hadoop, use the power of the cluster that we're working against, and pull the aggregated results back, and then surfacing that out to the end tools. So let's see how that actually works. So if we talk about a query, select a bunch of columns from a table, in this case an external table, with some predicates, so where some details are. So the first thing that happens is PDW will go out and dynamically bind against HDFS. the next thing that will happen is we then go filter. So we say we're only looking for these particular sets of columns, and then we'll generate a MapReduce job that will pull down the specific sets of data. Just like you would expect a native SQL Server PDW table to happen, but this is happening across real time into Hadoop. We call this predicate pushdown. So we're binding all of the data and doing our filtering through a MapReduce job on the fly. On the fly. So I figured now's a great time to, instead of talking about this the entire time, let's show you. So we're going to slide on down here, and we're going to use our AdventureWorks Parallel Data Warehouse database. And what we're going to do, the first thing we're going to do is we're going to see the connectivity configuration. So I'm going to run a quick SPconfigure, and it's going to show me the results. And I'm going to zoom this out, or zoom this in. For some reason, my zoom went away. And what you can see down here is that we have a new configuration option, Hadoop connectivity. And there's some set values. So you can see that currently we're set at run value 1. And if we go back and take a look, you can see that that means that we're going to run against Hortonworks for Windows Server, HTTP 1.3, HDInsight running either locally on the appliance or as part of Windows Azure running in the cloud. So that's how I've configured this virtual instance of PDW to run. So it means that we can connect to the different variations of the appliance. In this case, this is AdventureWorks, so I'm going to create my version of a table. And in this case, we're going to use some of the power of the multi-parallel processing components of the appliance. And in this case, we're going to use cluster column index, which is the new indexing model available in SQL Server. And we're going to create a distribution. And I won't dive too deep here on what distributions are, but it's essentially the way that we're going to shard the data across the individual compute nodes within the appliance. And you can see I'm running just a simple select out of the fact internet sales table, and I'm doing some conversions here on date, just because I want them in a date format, not in the int format in the basic data set. So if I go ahead and run this query, you'll see that essentially I'm just creating a little over 60,000 rows into a secondary table here. We can go take a look and see what's in that data. And I really want to show you kind of a guidance on what the data is. So you can see we've got a couple of years worth of data. This is early 2000 data, so we've got 2001, 2002, 2003, and 2004, and just a small number of rows per year. Specifically, we're going to work on the year 2001 and 2002. So we have about 1,000 rows in year 2001, and about another 2,600 or 2,700 in year 2002. So now as we move through this, let's talk about how we would connect Hadoop into PDW. So the first concept to get is the concept of an external data source. So if you look at an external data sources, similar to how you would connect an ODBC or OLADB or a SQL Server native connection to another data source. In this case, it's very similar. We have introduced the concept of an external data source within PDW, and it has some distinct kind of flavors about it. In this case, we're telling it we want to connect to Hadoop, and then we're giving it some information. In this case, the line that we're showing is the cluster of Hadoop that we're going to run against. It happens to be local on this virtual appliance. As well as then the job tracker node to allow us to create MapReduce jobs and execute them within the Hadoop cluster. So I'm going to go ahead and run this, and you'll see this will return very quickly. It's just created the data source. It's done nothing other than that. The second thing we'll then have to do is create an external file format. So what does the data kind of look like? What format is it in? How is it separated? In this case, I'm using CSV, so comma separated value delimited format. And you can see we create this concept of a file format, which marks to a particular type of file format. It's pretty straightforward. We're telling it it's delimited text and that we're going to use commas as the delimiter. So we'll go ahead and run that. After we move on to that, now let's talk about how we would cold source data. So we have our fact sales table, but it contains that 2001 data, and we don't really want to look at it every day. We don't want to have it impact the performance of our queries, so we want to move it into a cold store where we're able to get at it if we want, but it doesn't impact it doesn't impact the day-to-day business of running our business. So what you'll see is there's this new syntax, create external table. In this case, I've called it fact sales 2001, and I've noted that it's out in Hadoop. You can see the location in Hadoop in the HDFS file share or file system where I'm going to push the data. I'm going to use the data source that we talked about above, so I could connect to multiple different Hadoop clusters at a time if I wanted to. So Hadoop running locally in my environment or also up in the cloud. What file format I want to push the data in. And then in this case, we call this a create external table as select, and so a CETAS. And in this case, I'm going to select the data that I want to push into there. So in this case, I'm going to go grab all of the rows for 2001. So if I go ahead and run this, what you'll see is that it'll take just a second to run. And what just happened was it took all of the data out of PDW, copied it, and pushed it into Hadoop. So if we go ahead and go over and look at the Hadoop infrastructure that's running under here. And you can see I've got a couple different views of Hadoop. You'll see that I've got the web interface that comes with Hadoop or HDInsight locally. And if I do a quick refresh, you'll see that all of a sudden in that path, the data will show up. So here's that directory that we just created, and I have, again, two views of it. So we can look at the sales data here, or I can look at here in the Redgate HDFS Explorer. And if I actually use the HDFS Explorer, I can open one of these files, and it'll take a second to download to the machine here. And you can see there's my data, comma separated. So my specific date columns and some of the information that I was pulling out of PDW. So now we'll head back to here, and we're going to check to make sure that all of this was set the way that we want it. So we're going to look at some internal metadata tables that describe kind of what just has happened. So I have this external table. I'm connecting it to this location. Here's the job tracker, how I'm pushing the data, row terminators, file terminators, those kinds of, or column terminators. And you can really see all the infrastructure we built. So now let's go run a quick query. So I have that table now sitting out in Hadoop. Can I get data from it? Absolutely. You can see very quickly I was able to go out, grab the first 10 rows, and return it here in PDW. And again, from T-SQL component, this looks just like T-SQL that you would write for any other table, whether it resided in Hadoop or whether it was native to the appliance in PDW. So now let's do some fun stuff. Let's go back to our original fact table. We're going to go ahead and clear out those 2001 rows since we've moved it off into Hadoop. So we'll go out and we'll clean those 1,000 rows. Now, just like you would with any other type of table, I can union these or I could join them. In this case, I'm just going to union them. I'm going to grab the first 20 rows from each one of the tables. The fact table sitting currently on PDW, so that's running 2002, 2003, and 2004, as well as the 2000 data I just pushed out to Hadoop. And I'm using a simple union. I was able to grab 20 rows, 10 rows from each table. Again, you could join these. You could do anything that you would with a normal SQL Server table, now externally exposed as data stored in Hadoop. Now let's do something a little different. So in those basic scenarios I gave you, we don't really do push down. The reason we don't do a push down query is because the data is small enough. I'm only pulling 10 rows and I'm not doing any filtering. In this case, I'm going to go ahead and run a quick query. It grabs a couple of columns and has some predicates. So an order date between a period of days. So go ahead and run that. Oops. And what you'll see is that what just occurred was PDW evaluated this, so this is query plan optimization, generated a MapReduce job, pushed that down to the Hadoop cluster, ran the MapReduce job, returned the results to PDW, and surfaced it here as a result set. All right, so now let's play around a little bit. Let's have a little bit of fun. Since we're already using one format, we're going to create a different file format. In this case, we're going to use pipe delimited. So we'll pick just something else if your environment happens to be using a different terminator. So in this case, I created another file format using pipe delimiters. Now I'm going to create a secondary table. Again, very similar to how we created the first external table. But this one's going to be the 2002 data. I'm going to take this data and push it out into Hadoop. Now again, in this case, you can see I'm going to push it out into a specific location in HDFS. I'm going to use that same data source connection, but I'm going to use the different file format. So this data should come out pipe delimited. So I'll go ahead and execute that, and you can see that happens fairly quickly. Again, this is 2,600 rows, so it shouldn't take very long. But if we go back out to Hadoop and we bounce back up, you'll see that new set of rows and that data being pushed out. And if we take a look at one of these files, we'll pick one of the smaller ones here at the top, you'll see it's pipe delimited. So instead of using commas, we use pipes. Pretty straightforward, exactly like you would expect it to work. And again, we can go and always check to see how these are set up. So you can go look at the different tables. You can see they're pointed at different locations within HDFS, the full location. We're using the same job tracker since it's the same cluster. They're both delimited text, but we do have different field terminators. And I'll zoom here so you can see that. So the field terminator in the first one is a comma, and a pipe in the second. So it gives you the ability to have different sets of file formats based on the file structures you have coming in. So IIS logs may be tab delimited versus maybe the log from a network switch is different, or from a sensor from a car. So now let's join all three. So now we have our 2003, 2004 data in our fact sales table, and then we have our Hadoop comma delimited in our 2001 table, and then our pipe delimited data in our Hadoop 2002 table. So if we run a quick query, it returns exactly as you would expect. It gives us 30 rows. Even though the file formats are different, it's able to collapse them into a structure that is able to be joined just like any other table that you would expect. So the ability to move between different file formats and surface that as a traditional T-SQL table or a SQL Server table that you can then manage. You can secure, you can add user security, you can index over views, you can do all of the things that you would typically expect with SQL Server run on these now very visible external Hadoop tables. So now we're going to take this a little bit further. So we're going to take the role of we take all of our Twitter data and we shove that pipeline of data we get from Twitter into files sitting in Hadoop. And now we want to expose that. So really we're using Hadoop in this case as the file store and the staging location of this data. What we're not going to do is we're not actually going to move the data. So we're going to create a table inside of PDW that's still a representation of data that was originated in Hadoop. So we're not moving data to Hadoop, we're pulling data from, but we're doing it on the fly. In this case, you can see it's just a fairly straightforward table, a bunch of different columns, some different details. But you can see I'm asking for where that data lives. So I'm providing the location for the table, saying it's in this HDFS path, what connection I'm going to use for it, and then how I'm going to get at it. So in this case, it's pipe delimited. So if I go ahead and run this, this will take just a second to run. You can see this is fairly quick. Again, we're not moving data, so it doesn't really matter the source of this. In this case, it's about 700,000 rows. So it's a fairly large data set. You can see it move very quickly. And again, if I go run a quick query, you'll see that this will take a second for it to spool up as it's 700,000 rows, and it's the first time I hit it, so it's cold data. But it took about 7 seconds for us to generate a job out to the Hadoop cluster and return the data back. And you can see it's fully baked like any other T-SQL table. But now we can do something else. So let's go back to that MapReduce concept. We'll do a quick count of all of the tweets where the person who tweeted it had more than 1,000 followers. You can see faster than I could actually speak the statement of what I was trying to do, we were able to return the results very quickly. And again, this infrastructure I'm running on is a virtualized environment. Our appliances are much, much quicker than this. But I'm sure there are a few DBAs in this crowd, and they're wondering, well, it looks like an external table, so it looks like any normal table, but what can I do with it? How do I manage it? What about staleness over time? How do our query plans optimize? All of those kinds of basic maintenance operations that you would perform on a traditional PDW table, T-SQL table. How do I do that inside of now this external table running against Hadoop? Well, just like you would expect, we have all of the basic functions that you would expect. You can create indexes across them, and here you can see I'm going to go create some statistics against that external table that we just generated, where the data still lives in Hadoop. And I'll go ahead and run this, and you'll see in this case it's going to run against 700,000 rows, and the statistics creation happened very quickly. It took less than a second here on this machine. So now let's go back and we're going to do some aggregation. So the last thing we'll do here is, again, we're going to run that same query. Slightly different variations. So we're going to go look and see how many times do we get an impression or a tweet that talks about our product, and we're going to organize it based on date, and we're just going to do a simple count. And you can see I returned from 700,000 rows very quickly in just a virtual machine, very quickly the ability to get all that data very fast using the statistics I just created. So really using the power of the appliance very, very effectively. So we'll hop back on over to the presentation. And we'll talk about kind of the PDW running at scale. So there's a couple components of PDW that are implemented that allow you to scale up. Some of these are the traditional problems with scale up in data warehouses. So you have this forklift model of, well, if I want it to run faster, I need to buy a bigger server or a bigger set of servers or a larger SAN. And really you get kind of diminishing scale. The second is the optimization of row indexes in traditional data warehousing. So data warehouses traditionally sort indexes by row, but data warehouses tables are generally very wide. We remove the normalization patterns that are typical, and instead we query across those rows. And it really provides suboptimal performance when there's very large data sets that you're working against. Pulling all of those rows back is very inefficient. So really there's a couple of technologies in APS that really enhance the way that this is done. The first is that the appliance itself has the ability to scale out with multiple nodes running dedicated CPU, memory, and storage. And the appliance has the ability to scale incrementally, near linearly, all the way up to 6 to 7 petabytes. We can grow very large, very fast. We can handle queries that are running across hundreds of millions or hundreds of billions or hundreds of trillions or quintillions even of rows of data in a single table spread across multiple nodes. And this allows us to generate an appliance that looks very simple, all the way from what we call a quarter node with just a couple of individual compute nodes, all the way up into very large appliances, multiple racks of servers that interact as a single kind of operational component. We don't have to scale out the appliance using larger and larger servers. Instead, we can add additional nodes, similar to like a Hadoop model, where you can add just additional compute and storage capacity, and the appliance just grows with you. And really, that scale allows you to get to massive amounts of scale. So really solving that number of petabytes problem that many companies have, adding 100 gigs, 1,000 or 100 terabytes a day in some instances of data into this appliance. And then the second thing is really using kind of cluster and column index, the custom column store index, and really using the ability of in-memory kind of column store to not only compress the data being stored in a table, but allow it to service the data warehousing kind of workloads that are typically seen in large data warehouses, taking individual columns out of a denormalized table and being able to reference those back. And really what that means is in many cases, in the chart here you can see an example of the way that we can save not only storage space and compress the amount of data that you can push into that potential 6 petabytes, but also you can buy smaller appliances, you can buy cheaper hardware, and really drive down the cost of actually doing a very large data warehouse from the traditional way that it's been done. So really what this means is that you have the ability to run very kind of concurrent workloads, so traditional ETL, ELT tools, SSIS, MDS, those types of things coming out of your kind of traditional systems. We have a cool tool called DW Loader, which is essentially BCP but on steroids, that allows you to load very, very quickly. And using column store, being able to store that data within the appliance. Being able to use PolyBase to surface data from Hadoop and other solutions, as well as just kind of ad hoc queries into the appliance. And then being able to push that data around into CRTAS, into external systems, using the ROLAP and MOLAP direct query models out of SSAS to be able to get data out of the appliance and use the power of computation in the appliance and surface it near real time in those systems. The traditional BI tools, Excel, and reporting services, as well as many of the third-party tools that connect to PDW and allow you to do analytics and insight against it. We'll then talk about kind of the speed of the appliance. So really using kind of the column store infrastructure and the way that data is now stored, as well as kind of the parallel query execution. So when a query comes in, the individual nodes go out and actually work on the set of data that they own and be able to return results very quickly. We see things like 100x performance improvements against queries. We see 15x compression on the data being stored. A great sample is that we had a customer who moved just a traditional once a quarter sales report that would take 13.5 hours against an S&P instance, and through optimizations we were able to bring that down into just under 3 minutes. A massive improvement in their ability to get insight into the data. So they no longer run that once a month, they run it every single day. And then finally, kind of the optimal value of the appliance. So we really want to talk about how Microsoft has brought to the market really truly a data warehousing appliance that's not only effective as far as operational business, but also cost effective. It's really an important component to think about these large scale systems with many disks and many drives and how we scale the business, but not breaking the budget at the same time. So there was a comparison done by an independent company that went out and looked at the primary systems that are building kind of data warehouse appliances, and Microsoft was very competitive, and you can see here leads the pack in price per terabyte for all of the leading vendors that are available selling appliances today. It means that really truly buying an appliance from Microsoft gives you the ability to use either a smaller appliance based on the technologies that are enabled, column store, for example, cluster column store, for example, or it means that you have the ability to buy a larger appliance for the same cost and have the ability to shove more and more data into it and get more insight from your business. It's the same cost as you would buy a less performant from one of our competitors. We do this by a couple of different ways. One is obviously component hardware from our IHV partners. We're able to pick off the shelf a lot of components that our competitors can't. We use the power of Windows Server 2012, things like storage spaces to remove the requirement for things like dedicated hard drives. We went to commodity storage through JBOD storage, and we were really able to drive the price down and really keep the performance of the appliance at par or above our competitors by using, commodity hardware. And we really use the advantage of the power of the scale of Microsoft and the reach of Microsoft and all of the different aspects of the company to put together a solution that allows us to really, really target the way that this appliance comes to market. So I'm gonna end here. Really, if there's a couple things here. If you want to learn a little bit more about APS, you can visit us at microsoft.com/APS. Or if you want to try HDInsight, you can learn a little bit more about that at microsoft.com/bigdata. And I believe we're at about the 50-minute mark, and this is the last kind of 10 minutes here of this presentation. If there's anybody that would like to ask questions, we'll take questions for about 10 minutes, I believe, before the session will end.
Okay, Matt, thank you. Really great stuff. And we do have a couple of questions that got queued up while you were talking. First one is someone mentioned he heard about Dell and HP and asked if there were any appliances from Quanta.
So yes, there are. Quanta is the third partner. They become a recent IHV partner for us, and we've already sold and deployed a few of these already out into the field. We have customers running actively on Quanta appliances in production.
Excellent. Second question, and this is actually a great question. It's a pain point that I've had when PDW was coming out in the first couple of versions. Are there any virtual labs or online demos set up where you can go try out APS and PDW before trying or deciding to buy it?
That's a great question. Currently there is not, unfortunately, but I can say that it's an area that we're very aware of and something that we are working on. So we will have something in the near future to discuss about virtual labs or tryouts, those kinds of things. I will say that at some of the tech conferences, so Tech Ed, for example, we did have the opportunity for folks to try an appliance. It was actually there on the showroom floor. We had a running appliance where people could come in and interact with the appliance and ask questions of the folks who actually engineer and deliver this appliance. So we will be having more opportunities like that.
So can I assume then you'll have one at the PASS Summit coming up in a few months?
We're working on it, so I don't know the details yet, but it would be something that we'd love to do.
Sure. One more great reason for people to come. Suppose you're not at a conference. What would be the right way if you were interested in going and checking out APS? What would be the best way to go about doing that then?
So we have a set of local account service reps all over the world, and you can connect with one of them, and you can they can give you access to an appliance through the sales process, or if you're really interested in kind of learning more about the appliance, they can definitely work with you to find a solution that works for you.
Okay, great. And next question is actually from a couple of folks. There's a little bit of confusion around where APS fits into the picture, and is it something that is part of the SQL Server installation, or is this a separate beast all to itself, a separate product that you'd have to install?
Got it. That's a terrific question. It is not a part of the box product. PDW is actually sold as a complete unit, so you would buy the hardware and software together as a completed unit. So it literally shows up as a rack of servers pre-configured with SQL Server, Windows Server, everything on it available to you. You plug it into your network and just turn it on, essentially, and it becomes available as a data warehouse to you. It's not something that's configured as a software-only solution.
Okay. And the last question that we have so far is what's the average cost of a full rack system, and do these systems utilize solid-state drive?
So to be flat honest, actually, I do know some of the latest sales numbers, but I don't know the accurate sales numbers, so I don't represent them here incorrectly. So, but if you do have a question about that, definitely reach out to one of your local account reps. They can give you the details better than I can. The second question was around solid-state drives. We are currently evaluating them. The appliances that we sell today do not have solid-state drives. We do still run platters and disks. And we have evaluated them. The concern that we have is the reliability of solid-state drives at a very large data warehouse environment. So we have evaluated them, and we haven't found them to be as cost-effective yet as we'd like to see, compared against duration and the ability for the appliance to stay alive with the drives not failing. But it's something that we constantly evaluate. We balance the ability to run very quickly from a data warehouse workload against the cost and the ongoing maintenance and operations that a company would have to take on as a responsibility with solid-state drives. So we're in this balanced state of always looking at it and trying to understand when's the right opportunity to expose, technologies like solid-state drives or, improve networking infrastructure in the appliance in a cost-effective way. So directly, the answer is no, we don't have solid-state drives now, but it's something we constantly evaluate of when is the right time to pull it in.
Okay, good. And we did have one more question pop up. Since APS consolidates data from so many different sources, does Microsoft have any plans to spin up their own version of any kind of a NoSQL database?
That's a great question. I actually don't know. Microsoft's a large organization, so I don't know what some of the other divisions are doing. So I have no direct knowledge of it, but from our perspective, looking at the internal, systems that are available, looking at the external companies that are out doing things, looking at the Amazons of the world or the Mongos of the world and some of these NoSQL or document-oriented databases. Our approach from PDW has always been, let's not have people go out and have to learn new systems if they don't need to. There's the folks that are maybe implementing, like a developer who may be implementing MongoDB in your environment and using that as a repository for some OLTP system or CMS system or anything like that. But really, the folks that are doing analytics or reporting or data scientists, they don't need to go learn those new tools. We can use the power of PolyBase to be able to pull that data in a way that's familiar with them to the tools that they're used to using. So our approach has always been from PDW. We will work with the external vendors, the open source community to find ways that we can use the technology and leverage it in harmony with PDW, not as a this or that kind of model. Does that make sense?
Sure, and actually from what I see, my perspective is you have a pretty healthy partnership with Cloudera already, so it seems like you don't want to reinvent the wheel there since they've got a pretty good open source Hadoop product as it is.
Yeah, absolutely. We work with Cloudera and Hortonworks, quite a bit. We talk to them. We're very close to each other. We actually do a lot of deals together where both solutions are put in play at customer sites, and so it's a great partnership between the companies.
Okay. And we have two more quick questions that popped up while we still have
Sure.
a minute. If you have an issue, so let's say you get into an APS system and you have some sort of an issue, do you have to work with Microsoft exclusively on it, or do you end up having to go and talk to hardware vendors for the pricing of the solution and fixes to things, or is there just one path that goes through Microsoft when you have APS questions and issues?
This is terrific. There's some really great questions, and this is another one. So terrific question. So Microsoft, as part of the APS appliance sell, is a tier 1 support for all of the appliance. So if you have an issue, whether it's hardware related or whether it's software related, Microsoft is the tier 1 person that you call. There's a dedicated support engineer for each appliance as part of the support contract with the appliance, as well as dedicated structured support for APS specifically. So you get put into the large Microsoft CSS pool and get pushed around. Instead, you come directly to a set of representatives that are specifically working on the appliance. If that happens to be the case where, say, a hard drive dies, Microsoft is your first and only phone call, and we will coordinate with the IHV vendor to be on site to fix it. And you'll have maintenance contracts and SLAs for each one of these things. So the hardware component vendors will provide typical SLAs that you would expect in tier 0, tier 1 production environments. So 4-hour response times for hardware failures, those kinds of things. So, but Microsoft is directly your single point of contact for the entire appliance.
Great. Quick question around terminology. Is APS equivalent to PDW, or is PDW a part of APS?
So another great question. It's actually the latter, where APS is the new name for the appliance, and PDW, the scale-out SQL Server data warehousing component, is now one of the regions that runs inside of APS. In the latest release, we introduced the HDInsight region, which allows you to run HDInsight and PDW inside of APS. So APS is the umbrella representing the appliance, and PDW is a workload within it.
Great. Well, Matt, thank you very much. Unfortunately, we are out of time for questions. There were one or two others that came in. I'll try to follow up on those if we can through email, see if I can get folks some answers to those. But we really appreciate your time, and really good stuff. Really interesting clarification on how APS works and PDW works. So thank you very much for your time.
You're welcome. Thank you, everybody, for attending. And if you have any questions, feel free to reach out to me on Twitter, and I can follow up there as well.
Great. Thanks, Matt.